Good morning, children. Now we'll continue the class now. That's for 6th standard science, that is lesson 3, matter around us. So in the previous class we saw about the matter. So what did we say? That matter is defined as an occupying space and has mass. And we saw about the diffusion and the differentiation between the particles of solid, liquid and gas. Now we'll continue the page number 42. Now the activity is given here, children. Lift an inflated cycle tube, that is cycle tube irukku adu air illama irukku that is inflated cycle tube. Inflated, now you have to put the air there in the cycle tube la. Inflated and now lift it again. So what the difference will you see? That is, if there is a change in the weight, they are asking. Can we say that air has mass? So we can say that air is also matter. Okay, so the air is also a matter. Though we cannot see, it occupies a space and has mass. So air is also a matter, but we cannot see. So though we cannot see, we can it occupies a space and it has mass also. So from this, what do we infer? We infer that the matter has different properties. Then activity 5 they are given here, children. Let us take 2 sachets, that is 2 packets of juice. In both the sachet, it is written 100 ml. How much? 100. Let us empty 2 sachets. We have to empty that packet, that is 2 sachets, and pour the juice into the glasses. These are the following glasses. So we are pouring it. So the glasses varies, children. So you have to pour the juice into the following glasses. So the question asked is, does its shape also change? You have to say yes or no. And another question is, does its volume change when it is poured into a big glass or a small one? Here also yes or no they have asked. You have to write the answer. How will you find out whether the volume has changed or not? These are the questions. The answer for this is, the liquid needs a container and takes the shape of the container. For example, the juice is poured. Okay, it takes this shape of the container in this glass. This glass, see, it varies. When you pour the juice, this takes the shape of the container. Both the glasses are different, but it takes the shape of the container when the juice is poured. Then shape of the container, because these particles slide one another and start moving. The amount of juice is same in both the glasses. That is 100 ml only we are taking in both the glasses. So the amount is the same. So the volume of the liquid remains the same. That is, the volume is the amount that we are pouring in the glass. That is a juice, that is 100 ml. The volume is the same. So whether it is kept in a large container or a small one. Okay, whether we pour it in the large or the small, the volume is the same. But its shape changes. See, here there is a small container. Here the shape changes. Here the large. Here also the shape changes. So the volume is same, but the shape changes. Okay, volume is same, but the shape changes. So now how will you put here? Here the question is asked, does its shape also change? That is yes. Okay, does its volume change? No. So no will be the answer. Next we'll see compressibility of gases compared to liquids and solids. Now first they have taken 3 syringes, that is 3 syringe piston here. One, next one is two, next one here, three. Okay, so now in the first one, after removing the plunger, that is after removing it, first let us fill it with chalk powder. So after removing this, what you have to put there? Chalk powder. You have to fill it with chalk powder in the first syringe. Okay, then try to press plunger down. This has to be press. Okay, press the plunger down. What do you observe? This is the first question. Now the second one. Now let us fill the second one with water. So what you are going to pour here? Water. So water. So this is the plunger. Okay. So now what you are pouring? You are pouring the water in the second one. There what do you observe? Then let us now draw the piston back to suck air into the third one. That is fully you're putting it inside the plunger. Press the plunger down. You have to press the plunger down. What do we observe? Is it easy or hard to press? What they are asking? Easy arka or hard arka to press they are asking. So for the first one, what they are using? They are using the chalk powder. Then the second one, they are using water. And the third one, only air. Okay, so these are the 3 syringes. Now record your observations and share among the group members they have asked. You would have observed that the plunger moved freely in syringe with air than in water. So this one is the easiest one. Okay, so when you press it, it moves easier where the air is there than in the water. So it was difficult to press and the piston hardly moved. In the chalk powder, okay, here in the chalk powder, it is hard to press the plunger. So we conclude gases are highly compressible compared to the liquids and gases. So once again I tell you children, these are the 3 syringes we are taking. In the first one we are using chalk powder, the second one water, and the third one only the air. So in the liquid what happens, next what you have to do, you have to press the plunger. So when you are pressing the plunger, so which will be the easiest one that is filled with? That is only the air. Okay, you have only the air, it will be easier for you to press, while than the liquid. Okay, it will be easier. This is little hard, water, and chalk powder you cannot even press it. So it's very hard to press. So which is the easiest one? Gas. Okay, so compared to gases are highly compressible compared to the liquid and gases. These are highly compressible. Okay, highly compressible compared to liquid and solids. Then they have given. So we are going to summarize now about this in solids, liquid and gases. Now first we saw solid, we are going to see now. Solids have definite shape and volume. So I already said solids have definite shape and volume. Liquids, they have no definite shape. Liquids take the shape of the container in which they are kept. I already said they take the shape of the container. So the liquids attain the shape of the vessel, means any container. Okay, vessel or container you can say. Take the shape of the container in which they are kept. And gases, if you see, gases have neither a definite shape nor a definite volume. For example, if the balloon is filled with air, this have shape? No. So they don't have shape, no definite shape, nor the definite volume. Okay. Then second point is the incompressible. Compressible alutham solraniya. So for example, if you take a brick or a stone, can you compress it? No. So it is hard. You cannot compress. So it is incompressible. Then if you take liquids, compressible to a small extent. Amma vandu konjama adu compress agum. Then gases are highly compressible. If you take a balloon, you can compress it nicely. Yeah, so they are highly compressible. So solids are incompressible. Liquids compressible to a little extent. And gases, they are highly compressible. These 2 points you know thoroughly now. Now we will go to the third point. I already took this during the differentiation of solid, liquid and gas. So now we are going to summarize it this one. There is a little space between the particles of solid. That is, they are tightly packed or tightly arranged. Okay, there is only a little space in the solid because they are tightly arranged or the packed. Then liquids, these particles have greater space between them. That is, they are greater than the space they have, the greater than the solids. And particles are not tightly packed or arranged and they are free to move. So they are not like solids. Since the solids are tightly packed, but in the liquids, they are loosely packed and they are moved freely. Then in the gases, if you take the space between gas particles greatest. So solids, liquids, if you compare in the gases, they are greatest. And particles are very loosely packed or arranged. Okay children, in the solid, the space between the particles of the solid is little and they are tightly packed or arranged. In the liquids, these have a greater space between them and they are not tightly packed like the solids and they are free to move. And in the gases, if you compare with the solid and the liquid, they are these gas particles, space between them is the greatest and they are very loosely packed or arranged. So this is the 3 points. The next point is these particles attract each other very strongly. So they attract each other. Then the liquids, the force of attraction between the liquid is less than solid. So in the solid, what happened? The force of attraction is very strong when compared to the liquid. Okay, in the liquids, attraction is less than the solids. And the force of attraction in gases, what happens? The least between gaseous particles. The next is the particles of solid cannot move freely. So the particles cannot move because they are very tightly packed, so they cannot move freely. Then in the liquids, these particles move freely, and in the gas, they are in a continuous or in the random, that is, they can move very freely. So these are the 5 points, children. So once again we can see, that is, solids have definite shape and volume. Liquids do not have the definite shape, and they take the shape of the vessel or the container in which they are kept. But the gases, they neither have a definite shape nor definite volume. And the second point, what we saw, that is, they are incompressible. Solids are incompressible. Liquids, they are compressible to some extent. And here in the gases, they are highly compressible. Then in the solids, next point, what we saw? There is a little space between the particles of the solid, and they are very tightly packed. But in the liquids, what happens? The particles have a greater space rather than the solids, and they are not tightly packed or arranged, and they can move freely. Since they are not tightly packed, they can move freely. Then the space between the particles is the greatest, more greater than the solid and the liquid, and they are very loosely packed or arranged. Then the next point, what saw? These particles, they attract each other very strongly. But in the liquids, the force of attraction is less than the solid. Then the force of attraction in the gas is very least between the gaseous particles. Next, the last point, what? Particles of solid cannot move. Why? Because it is tightly packed, so they cannot move freely. Then these particles in the liquid move freely, and in the gas, they can move very freely. So these are the 5 points. We should be thorough with this 5 points, children, and this is very important also. Then next we will go to the matter, that is pure substance and mixture. Pure substance, that is, we are going to see the pure substance as well as the mixture. Matter, pure substance and mixture. So in this pure substance, again it is classified into two, that is element and compound, and here mixture, that is homogeneous and heterogeneous mixture. Homogeneous and heterogeneous mixture. This is again classified into two. Okay, children. So matter is divided into, that is pure substance and mixture. And in this pure substance, they are classified into two, that is element and the compound. And in the mixture, again divided into two, that is homogeneous and heterogeneous. Now, if you take element, children, what is element? So it's a pure substance which cannot be broken down, and it consists of atoms. So what is element? It's a pure substance which cannot be broken down, and it has atoms. And if you take compound, it has atom from it has more than one element. So it is an atom which has more than one element. So for example, if you can say, that is air. Okay. So here for the element they have given milk here, and for the compound they have given water here. So okay. Then homogeneous, if you take, that's a solid, liquid and gaseous mixture. Okay, what is that? Solid, liquid and gaseous mixture, that is homogeneous mix. For this you can say example, air. Okay. And that is heterogeneous, it's a non-uniform mixture. It's not in a uniform, so it's a non-uniform mixture. Now, see here. In shops, we find products which are sold with label 100% pure. So when we go to the shops, what we will see that they have given 100%. For example, if you buy oil, they will say that 100% pure. But for common people, pure means unadulterated. That is, it is pure, okay. Does not contain any cheap or harmful additives, any harmful chemicals. That means 100% pure means what we will think? That it's very pure, you don't have any chemicals added, like that we will think. So for us it is unadulterated. So unadulterated means it's very pure. Now are they really pure as they claim to be? So for a chemist, the word pure means something else. So for a chemist, pure means something else. Pure means what? Something else. That is, you have something there. Pure னால நம்ம வந்து ஒரு இதுல வரும், மைண்ட்ல வரும், ஏதோ அதுல இருக்கு அப்படினு இல்லையா? So something else. A pure substance is made up of only one kind of particles. A pure substance made up of only one kind of particles. Contain one kind of particles. So next, pure substance may be elements or compounds. Elements, so already explained what is element and compound, children. So pure substance may contain element or compound. An element is made up of same kind of atoms, that is consists of only same kind of atoms in element, okay. So element has a same kind of atoms. Next, molecule is a combination of two or more atoms. So two or more atoms, that is combination. Molecule is a combination of two or more atoms. Now compound is a substance formed by the chemical combination of two or more elements. Chemical combination of two or more elements, that is compound, okay. Compounds are the chemical combination of two or more elements. Then mixture is a physical combination of two or more substances. So mixture is a physical combination, okay, of two or more substances. Two or more substances, okay children. So what we saw, that is, it is a pure substance is a one kind of particles, and pure substance may be element or a compound, and the element has a same kind of atoms, and the molecules are the combination of two or more atoms, and here compounds are the combination of the chemical combination of the two or more element, and mixture is a physical combination of two or more substances. Then for example, see, we have had the snacks. Can you identify and mention a few things that are present in a snacks? Okay, like mixture or fruit mixture. You are able to identify the ingredients in them from their colors, appearance or the taste. For example, we mix rice, dal, salt, chilies, pepper, ghee and other ingredients to make pongal. So your mother will be making pongal for you, okay. Avanga enna ingredients adula use pandranga, like dal, rice, chilies, pepper, idu ellame ingredients nama pongal la podrom illaya. These are the things. So pongal is also example of mixture. The nari ingredients use pandrolliya, that is mixture. Kalavai nu solrolliya, that is a mixture, that is a ingredients to make pongal. The pongal is also an example for mixture. Why do we call these as mixture? Because they are made of two or more ingredients or components that are physically separable, okay. So why do we call them as mixture? That is, they are made up of two or more components or ingredients we can say. So that is, they are called as a physically separable. Then let us compare the vegetable salad and soda water. So if we take vegetable salad, the individual vegetable can be separated physically. So nama salad, vegetable salad, nariya vegetables use pannum, but we can separate that vegetables, okay. Physically we can, physically nama kaiyale edukalam, physically separated. In soda water, we can neither see nor separate the components. நம்ம soda water குடிக்கிறோம், என்ன components இருக்கு நமக்கு தெரியுதா? தெரியாது. So we cannot see nor we can separate the components physically. Then air is a mixture because it contains oxygen, nitrogen, carbon dioxide, water vapor, gas, noble gas and other gases. So air is a mixture of, that is oxygen, nitrogen, carbon dioxide, water vapor, gas and other gases. And milk is also, so air is a mixture I said. So I will see the other example like milk. milk is also a mixture. It contains water, protein, fat. Okay. Now if you take lemon juice also, it is a mixture. Some of us like it less sweet, that is with less sugar. So kammiyana sugar potu sila perukku pidikum. While some others like it very sweet, sila perukku vandu romba sweet ah irukonu irukum. So they prefer to add more sugar. But either way, it is still lemon juice. Adu eppadi potalum it is lemon juice. Iniya prepared from lemon extract, water and sugar, and is a mixture. So sugar, water, lemon juice idu ellame nama sethu podradala it is a mixture. So various ingredients are added there. Then its added is different. Same way, even if we add extra water to lemon extract, it is also a mixture. So nama edha nama extra potalum it's a mixture only. So a mixture need not have a fixed proportion of components. அதாவது இது இவ்வளவுதான் போடணும் அது அவ்வளவுதான் போடணும்னு கிடையாது. You can add more or you can add less sugar like that. Even you can add more water or less water, you can use it. So it's a no equal proportion for the components. So a mixture is an impure substance and contain more than one kind of particle. So for example, இப்போ lemon juice ஒரு kind மட்டும் தான் வெறும் sugar மட்டும் தான் யூஸ் பண்ணுமா கிடையாது. So sugar, lemon is a water is a impure substances and contain more than one kind of particles. And in the mixture, the components are mixed in any proportion, and the fixed proportion கிடையாது. More or less or more, we can add anything. So when elements chemically combine, they form compounds. So when elements combine, they form compounds. So whereas a mixture can be a physical combination. அதாவது நம்ம mixture நம்ம பண்றோம் இல்லையா, இப்போ நம்ம lemon juice பண்ணோம், physically தான் பண்ணோம் இல்லையா. So it is a physical combination. So two or more examples, two or more elements. Example, 22 karat gold, which is composed of gold and copper, or gold and cadmium. Then two or more compounds, if we take example is aerated drinks. Aerated means the cool drinks that we drink is composed of carbon dioxide, water, sweetening and the coloring agent. So we use the color there. For example, Fanta, so orange color is there, sweet is there. So carbon dioxide is added, water is added there. So these aerated, that is two or more compounds are added. Then an element and compound, if we take example, tincture of iodine, composed of iodine in the alcohol. Then separation of mixtures we'll see in the next class, children. Thank you.